areas. What helped me do my universal force, being electromagnetic force, was the what happened to the Protestant Reformation and the King James Version of the Bible being available to Isaac Newton. And he wrote down a new scientific method that enabled me, not knowing actually that I was using it, but enabled me to find the universal force was electromagnetic. So that was unusual. And but when they discovered electromagnetic force in the 1850s, they didn't want to accept his scientific method anymore, and the people who weren't religious, and they started the God is dead movement as a result of that. So they were opposing the changes that were coming about, and they wanted electrodynamics, instead of being a universal force, just to be another force. You had gravity, you had magnetic force, you had inertial force, and you had electromagnetic force, and you had nuclear force, strong interaction force, et cetera, and all that kind of stuff. They wanted all these things to be separate. And they liked getting Nobel Prizes for each one of them. And so they didn't want to disprove the theories to show there was only one force, that was the electromagnetic force, because a lot of Nobel Prize winners would be unhappy, and they would politically try to stop you from what you were doing. And we have that going on today, I think, in terms of a universal force. So,
well, I sent you an email. I don't know if you got it. I sent it to several people that usually tune into these alternative meetings, pointing out that the Department of Energy now, the largest supporter of scientific grants in the U.S., has been given orders to prioritize inclusiveness and equity. Where
I don't know the difference between now and say 20 years ago, but I was the invited speaker for the American Physical Society, and on my work on the universal force. And when they realized at that meeting that my approach invalidated, I didn't emphasize this, but they realized it, invalidated the work of most of the Nobel Prize winners in physics, they decided they didn't want it. And so they had my recorded presentation deleted. They had my paper to go in the proceedings removed, and they called up the president of the university where I was working at the time, Catholic University, and told them to fire me the next day. And then president called up the chairman of the physics department where I was working, and told them we had to they had to fire me, because if they didn't, they were told that they would lose all their grants. And there were 27 people in the physics department that got all their salary from grants. And so, they didn't want to do that in the physics department. So the chairman told me that they had to formally fire me, but informally, they would pay me the salary I was getting, until I was able to get another job, because they didn't like what was being done. They were being forced to do this, and they couldn't afford to not do it. So anyway, that's my experience. And I had two other people I worked with who had a similar experience, because they published a paper with me. And one was at University of Virginia in Charlottesville, and the other one was at University of Louisiana in New Orleans. And so I felt very badly when I discovered that they were fired and they lost their job, and they were not quite ready to retire, but now they couldn't get another job as a physicist in a university.
Well, I've heard other people have had very bad experiences when they've tried to step out of line too.
Yeah. Well, you see, the people that invited me to this meeting of the American Physical Society, there were about 1,000 people in that audience. They thought my work was important, but the leaders of the government agencies that gave out the money for this lot of research, they didn't like it, and so they were a minority, but they had the power to get rid of me in terms
Well, they
of
controlled the money.
Yeah, they controlled the money, and so the universities themselves can't control the money. They're subservient to the government agencies that do have the money.
Yeah.
And so that was bad. And then from a person like myself, feel like, well, maybe we could get these new theories accepted if we found some application that you could work on that would be helpful. And I didn't actually participate in the most important one, but Elon Musk did. He saw the potential of these theories, electrodynamic theories, of to make new devices and patent them that could give us more energy. So, the cosmic background radiation energy panel resulted from that. And he invested the money and had people work on it until they got it to work. And then the second thing was the force of inertia was electromagnetic in origin. And so he was able to work with Boeing and also his own company, SpaceX, to get that to work using this cosmic background radiation energy panel. And so that way, with two things came out of it, and they had a lot of economic potential. For instance, the car that runs on inertial propulsion, even if you use wheels on it, it doesn't require paved roads. It doesn't require stoplights, stop signs. It doesn't require a lot of things, which we spend an awful lot of money on. And it makes it so that the GPS and stuff like that is very important, because it can take the car over land as if it was on a road, but it's not. It's just as the road is defined and for the GPS. And so that way you can save a lot of land. You can make things safer in the city because the car can be made to stop or bump up so that it doesn't hit something in the roadway. So people could be walking across the road while you're driving through that area, and your car would just go up 10 or 15 feet and over them, and then come back down and get close to the ground. So anyway, those are a lot of things that are there. And when people look at, well, how much money do we spend on this? And it's a huge amount. And you have to, on all the paved roads, every few years, you got to do some correction pavements, and because you've got cracks and holes in it and stuff like that. And so, economically, there's a lot of reasons to use this. And so what Elon Musk did is he recognized the opportunities that this technology would give. And And he realized that not only can it help the governments use less money, someone can make a lot of money. And so the first year he showed it off, he got $1.5 trillion given to him by 1,252 companies so that they could use it in their field and their with things that they make. And so, that was interesting. So we have a lot of people in our organization that are doing alternative theories, and they may not realize that they can get more people to accept their work if they have some application that it works on, or like making a car or making a spaceship, or making a boat that doesn't require any fuel but will go across the oceans and stuff like that. So anyway, that's a lot of things, and there may be other things you can do too. And I'm going to ask the question: what things have you thought about that could make your theory very acceptable to other people, and help them understand better, both mathematically and in their mind, what is going on? And so those are some of the things. But if there's no economic reason to do it and no benefits of it, it will get probably ignored if you can't find something that makes it valuable. So I didn't make it. I didn't do that. I didn't. I was afraid I would get further repercussions if I tried to do something like that. And I knew a lot of people like Steve Jobs, who's working with computers. And did you know his company fired him 2 or 3 times? He was unemployed. And you would say, whoa, why did that happen? And it was that people didn't like the way he did things, even though the net result was good. They just didn't like his attitude and all that kind of stuff. What can we do when politically people are opposed to our work? But how can we get the work accepted in society, even though these people who have a lot of the money don't like it? Because if they need to if they want to get that money, they will accept it. You know what I mean? And so I think that's why Elon Musk pursued this and patented it and stuff like that. Is he saw the potential for making a lot of money, and he started doing it. And by doing that, he became the richest man in the history of the world. And this work will probably reach all of our schools and universities.
What did he patent?
He patented the cosmic background radiation energy panel. It's like a solar panel, except that it produces 500 times as much energy per square inch as a solar panel. And it doesn't require any batteries because it works 24 hours a day. In other words, cosmic background radiation energy is coming from all directions to the Earth, not from just the sun. And so, it works whether it's dark or light. And it's so much energy you can put this panel in your basement of your house and still power your house with it. And people outside don't realize what you got. They don't know where it is. They don't know what's going on if you don't tell them or show them. Whereas if you have a solar panel, they can see it on the roof of your house, or they can see it in your yard, and they can steal it because they know it's there. They know where it is. And it only works in the daytime, and you have to have batteries to provide energy at night.
Well, my approach to trying to get inertial propulsion accepted is to create a child's toy based on the Milkovic oblique pendulum driven cart, which you can view on a video from Milkovic from, he's in Central Europe somewhere, has an organization, and one of the devices he's created is this oblique pendulum driven cart. And we're hoping to build a small toy IP device, inertial propulsion device, and sell it from a toy company. And so that would cut off the fact that the younger generation keeps getting brainwashed when they get to college. They would have this toy in their somewhere in their where they live, and they would know that what they're being told is nonsense.
Let's see, we have a number of people who are in the or are on the in the meeting so far. Some of you have developed theories that I believe you support, and you have this problem, may have this problem of getting it accepted by society. Do any of you have any comments on that?
We can't even get our theories accepted amongst us dissidents. So, you know, what's the hope of getting mainstream to accept it? So,
well, now, do you think dissidents will accept the work that Elon Musk is doing, like with his cosmic background radiation energy panel, a 1 foot square one, put in the basement of your house, will power everything in your house for the rest of your life?
probably not, unless you can actually stick one in the basement of my house. I mean, just as a general bystander, upon hearing that, I have to say that, well, that sounds great, but I'm pretty sure it's a fraud. So,
well,
you know, unless you can, you know, stick one in my basement, I'd love to have those things.
I'm extremely skeptical of that claim, and I know Elon Musk has come up with many what I consider to be harebrained ideas.
the way that he made most of his money with this cosmic background radiation energy panel is he invited 1,500 of the world's largest companies that might want to use that in their to a racetrack out west for 2 days. He invited them, and they came. They brought their executives. There were about 5,000 people there. And then the first day they were there, he brought out a Tesla car, which had a cosmic background radiation energy panel, 1 foot square, on the roof. He opened up the car so they could see that there were no batteries in the car, but it was a regular Tesla car other than that. And then after they did that, he closed the car up and then got a driver come out, and the driver drove the car around the racetrack from 0 to 400 miles per hour in 6 seconds, which is faster pretty much than any car in the past has ever been able to do. And because it doesn't use a battery, it could go faster than that, actually, and it could continue doing it for days without stopping. And so at the end of the day, he said, if you want to use this cosmic background radiation energy panel, which he says I've patented, you must give me $1 billion each company. That was the first day. And the second day, he brought out another Tesla car. This one was not a regular Tesla car. He opened it up so they could see it had no motor, no batteries, and no wheels. And after they saw that, it did have the cosmic background radiation energy panel. So after they saw that, he closed the car up and he took it, had the driver come out and turn it on. And when he turned it on, the car rose up above the ground because it didn't have any wheels. It was just sitting on the ground. And then he went around the racetrack, and he went from 0 to 400 miles per hour also in 6 seconds. Then he had them open up the gates at one end of the racetrack where there was a river there that was about a mile across. and there was no bridge there. And so he had the car taken and it went across the river and came back and didn't get wet. And everybody looked at that. And then he asked for 3 volunteers to sit in the car, and then they were going to go around the world. And they were going over oceans, continents, mountain ranges, all that sort of stuff. And he said, if you want to use this inertial propulsion, electromagnetic inertial propulsion, you must pay me $1 billion before the end of this month. Well, you could use both of them, just paying $1 billion. And 1,252 of the companies paid the $1 billion by the end of January 2019. That's a lot of money to invest. They were convinced that it was going to work. They don't think it could fudge. The people who were witnesses for going around the earth, they had their cell phones and they showed their pictures of all the continents, and they were from these companies. They didn't work for Elon Musk. So he didn't have, people out there just cheating people out of knowing what really happened. So anyway, Elon Musk has made other things, but he hasn't made as much money on those other things as he's made on this technology for cars. And he suggested that if you use his inertial propulsion car, which doesn't have to have wheels, or you could put wheels on it, but it wouldn't be a motor-driven thing. And you don't need roads, don't need paved roads. You don't need stoplights, stop signs. And so the country saves a lot of money, and the person who gets that for the car can drive that car for a lifetime and never have to get any more energy, because the cosmic background radiation energy is fine. And he can use the panel on the roof to power his house when he's home, so he doesn't have to pay for electricity from a power plant. And so, there's a lot of potential things there that people would like. And they will know if it works or doesn't work. And so anyway, 1,252 companies did that. Now, one thing that they did that Elon Musk is doing is he's helping them build plants for making the cars and other things using robots. And I don't know exactly why he's doing that. Maybe he's promoting the sale of robots, but it could be there's some radiation or something that's dangerous connected with this he hasn't mentioned, because he's the only one who's made a car, and his company would know about that. But I don't know the answer to that for sure.
Bill, do you have a reference on the internet to this meeting and so on?
There was a few people that reported it on TV, but and I saw one of them, but I wasn't there. I wasn't invited. I didn't know that he'd even patented this stuff until that information came out. And
So what's the patent number?
well, I don't know that.
The thing about the patent is that that's searchable. And
oh yeah, it's searchable. Yeah.
It should be under his name. Now, unfortunately, I'm right on the U.S. Patent Office website, and for some crazy reason, you can't search by first or last name. I don't know why that is. So I can neither confirm, and I mean, that was the first thing that people would search by, right? First and last name.
Yeah.
Now you type in Elon Musk and you get every single document that has the word Musk in it. So that doesn't help.
Yeah. Yeah. So
the thing is, if he patented it, then he would have had this deal about patents. So you would have had to have revealed exactly how to make one of these things, right? So it's like,
well,
it's just a matter of licensing.
What happened is I was working with my children. I didn't have a lot of money, and they wanted to go to good colleges. And so my second child wanted to go to Caltech first, and then he wanted to go to Harvard second. And he applied there. And even though he had gone to a science and tech high school and was graduating first in his class, Caltech said, we've never had a student from your high school come here, and we don't think you would work out very well because you don't learn as much in most of these high schools as you need to go to our college or university. So then when he went to this science fairs, he got first place at his high school science fair. He got first place at the regional science fair, the Princeton one for the Washington, D.C. area. And then by getting first place there, he was allowed to go to the International Science Fair. And NASA happened to be the judges at the International Science Fair. And they confirmed the work that he was doing and how you could potentially make these cosmic background radiation energy panels. And so they gave my son the grand prize at the International Science Fair, which was about $4,000. And my son called up Caltech and told them that he had won the grand prize at the International Science Fair. And they said, oh, we'll accept you as a student and we'll give you a full scholarship. And he called up Harvard, which is the #2 school he wanted to go to, and they said the same thing. They said they would accept him as a student and give him a full scholarship. So, but you see, the International Science Fair was open to the public. And so that's how Elon Musk found out about this. And I don't know if he himself personally did that, but someone who worked with him did.
If I could ask a question, it's the cosmic, the last time I checked, the cosmic background microwave radiation, the CMB, is very, very low temperature, which means low energy, okay? It's very cold, as it were. And what would be the incidence of the, or the flux of energy, say per square centimeter or square meter, on a surface from the CMB radiation? Has anyone even looked at that to evaluate whether it's even remotely possible that this very small amount of energy from the CMB could possibly do anything with the vehicle?
Well, the reason that my son got involved in this was when I was graduating from high school, we were in the space race with the Russians. And at the end of World War II, the Russians were the first to get into Germany, and they took out of Germany all the scientists and engineers that they thought were useful to them for high technology. And then the Americans came in because there was some competition between the various generals, and they were late as a result of that competition, and they only brought a few in. But then when they started putting satellites up, the Russians put up satellites that weighed tons, and they used lead to on the outside of the satellite to block all the radiation that was coming in. And because they knew that it could damage people. And we didn't know how much it would damage because we had not done that before. We put up satellites that weighed just a couple 100 pounds. And so we were trying to make progress, but we didn't have enough trained people. So what the government did is they rented Emory and Henry College for the summer as I was graduating, and they had the most outstanding high school graduating senior in science from each state they brought them to this Emory and Henry College, and they brought the best professors for science that would teach in the undergraduate area, and they gave them in 3 months a complete course from the best professors, and then they wanted to see if they could develop more capable scientists and engineers than we had been doing typically in our country. And I was selected for the state of Virginia, and we had tremendously hard tests in each of these courses, and I was one of the 2 best students that attended that session. And when I went to the College of William and Mary, where I had won the competitive examination scholarship in physics, which was not as big as some of these things that was going on the government was doing. But when I was there, and I told them I had all these courses, and they said, "Oh, those are the best professors in the United States." And so they said, "We don't know if you really learned anything. So what we're going to do is we're going to have you teach each of these courses, and we'll see if you can teach the students and get them to understand it." So I did. And every year I taught a number of courses, and they gave me credit for the course, and they paid me what a graduate student would make. And
Are we getting to the energy in joules per square centimeter per
when I was a
whatever?
When I was a freshman, I applied for a grant from the National Science Foundation. Normally, to get the grant, you have to have a PhD. I was an undergraduate freshman. I received a grant for over $100,000 to build a cosmic background radiation energy panel and to measure the polarization of the cosmic background radiation. Because the theories for the origin of cosmic background radiation could not tell you what the polarization would be. And they knew they were going to have this in space. So they wanted to know that. So I measured that, and I published a paper by the time of my senior year in the state of Virginia at a Virginia State Science Journal. Then, unknown to me at the time, 2 professors at Princeton University reproduced some of my work, not all of it, and they received a Nobel Prize for it, based on the information they learned about cosmic background radiation and the polarization. And so I had a background before I even got married and had my children, although I did get married when I was at William and Mary College. So anyway, I have a background there. And when I went to graduate school for my master's and PhD degree, I wanted to go to University of Maryland because they had the world's largest physics department with over 300 full-time faculty members. And so I got some scholarships to go there, and teaching. I was supposed to be a teaching assistant, but they had one of their largest courses, which was physics for pre-med. They couldn't find a good teacher that could teach it and get them to learn what they needed to learn. They were grading them on a curve, and you have to get an A or a B to go to medical school on this course. And so the previous people who had taught it didn't want to teach it anymore. And so I taught it as a first-year graduate student. I had over 1,000 students in this class, and I had 17 graduate teaching assistants working with me. And I got them to learn the course. This was a calculus-based physics course. I got them to learn the course and do very well, the way I was teaching it and the way I was testing. And the other professors said, well, you're not testing it the way we tested them. If you were to take those tests, you wouldn't do very well, because the people we taught didn't do very well. So I told my students that, and they said, oh, even though it won't count, we'll take this just to show them that we learned a lot more in your course than they taught when they were teaching the course. And these were all, were people with PhDs that were teaching. So, and I was that year selected by the dean of the graduate school as the most outstanding professor that year. And I was granted an award of half of my salary for the year. But normally, if a regular professor got that, he would have gotten a lot more money than I did. But anyway, they did do that. And John S. Toll, who was chairman of the physics department and later became the president of University of Maryland, he had a lot to do with that. So anyway, so I had a lot of background there. And
so basically, there is no answer to my question that you are able to provide.
Oh, not
It's
right
a
at the
minuscule
moment.
amount of. I'll just take a guess, a back of the envelope test guess that the amount of energy from cosmic from CMB radiation per square centimeter or square meter is minuscule and is orders of magnitude less than required to lift a Tesla car off the tarmac or a racetrack or to move it.
Okay. When I was a freshman, sophomore, junior, and senior at the College of William and Mary, I had access to some surplus equipment, and my father was a lawyer for a major government agency, and he had a Library of Congress library card, and I went there and checked out information on making certain types of detectors for cosmic background radiation. And I worked for about a year to 2 years on that before I was able to take my data. So my data, there were no commercial devices that could measure all this information about cosmic background radiation. And so I was able to measure it with stuff I had created. And the people at Princeton who got the Nobel Prize, they had to also make new detectors and stuff because none of the ones they were making worked. And the reason they didn't work was that they did not have a valid theory of the atom. And so they didn't know what was the source of cosmic background radiation, and they didn't know how to measure it. And
Do you have a reference on your paper here, Bill?
it's in my book.
Show them your book on the.
Here, I can show you the book. This is my book. It's called The Universal Force, Volume 1. And so by discovering the universal force, we were able to redo the theory of the atom so that now explains the origin of cosmic background radiation and the amount of energy and everything like that that is in that in the cosmic background radiation. Cosmic background radiation comes from hydrogen atoms. And it comes from, since hydrogen makes up about 80% of everything in the universe, that it has produces quite a lot of energy. And so anyway, that was done. And so I published a paper in a Virginia science journal. I can't remember the name of it right now, but and the people at Princeton, they published a lot of information too about what they did. And so those would be the places to go. But my theory of the atom has been objected to by many Nobel Prize winners because it disproved their theory. And I was working on a universal force theory, and of course, there is no recognition formally in the scientific community of a universal force. And I was able to derive the force of gravity from electrodynamics and all the other forces that we think exist. So that's the only approach that has been successful in doing this kind of work. However, I have been invited to all the major scientific countries of the world, including Russia, Ukraine, Germany, France, Spain, Great Britain, Canada, all of those countries. I have been given, they paid for my airfare to come. They gave me very fancy hotels to stay in and meals. And I was one of the principal speakers at the meetings I went to in those countries. They were interested in knowing more about it. They were not, the sciences in some of those countries like Russia was not politically controlled. They were interested in new technologies. And so that's why they would have people like me there. But in America, the universities didn't do that the same way. And as I spoke about this, I got fired from my university position for producing this work, which was politically incorrect, but it worked fine experimentally. So that's kind of the situation. And one of the questions I was going to ask was, what do we have to do when we have a new theory that's more comprehensive and complete than the currently accepted theories? But it turns out that my theory proof of my theory was based on Isaac Newton's scientific method, where he took the role of logic, inductive and deductive logic from the ancient Greeks, plus he added experiments to that in order to find better theories. And because of what he read in the Bible about God being the creator and sustainer of the universe, he believed that there would be a universal force. So he included in his scientific method how you would test if you had found the universal force and get a theory together. He wasn't able to do that in his day, but in the mid 1800s, when we started working on electrodynamics, the people following his scientific method believed that electrodynamics was the true universal force, and they believed the electromagnetic field was the spirit of God. So the people other people who are in the scientific area who are not in electrodynamics particularly, they hated that, and so they officially removed Isaac Newton's scientific method and replaced it with what's called the existential scientific method, which doesn't use logic properly. And that enabled them to keep the theories that they wanted. And and when that caused problems, they then went one step further to what's called the postmodern philosophy of science, which is the existential method, but each of the areas of natural philosophy has their own area of theories that are inconsistent with other areas. So, for instance, the chemists discovered that the force of gravity was electromagnetic in nature. They still use that, but physicists don't. We don't recognize that the force of gravity is electromagnetic in origin. And I was able to derive from my universal force the electromagnetic force as just a weaker term in the universal force theory. And you may not be aware of it, but Poincare in France, when the scientific method was changed to the existential method, he didn't like it, and he used logic and developed what's called meta theory, which is the theory of theories, and he published a number of what you call theorems in meta theory. And so one of the theorems proved that you could not have two fundamental theories that have a 1 over r squared dependence. You can only have one. And he published a number of these theories, theorems. And in America, what they did is they required every university to either destroy the publication of his papers and books or to lock them up and let no one see them, because they didn't want to let the information out of what was happening. I was at University of Maryland when I tried to get in that. We had one of the biggest libraries in the country for science, and the card catalog looks like they had the books there, but I couldn't find them. So I went to the librarian, who I personally knew, and asked them about it, and they said, we're not allowed to let anyone see this. It's been locked up. Not even the president, not even the chairman of the physics department or whatever can see them. And every college in America has been told to do the same thing, and they will lose their funding if they don't. And so then I had a fellow from Brazil who I knew pretty well. I met him at a scientific conference where we both were speaking in the Canary Islands for the state of the country of Spain. And I asked him if he would look when he was over there. He's going to be there for a year or for a postdoc type job. And he found that you couldn't get it even if you were in France. All the governments had agreed to remove this, so you couldn't see it. You can see references to it in other books, and you can see some of the theorems, but you don't see the proof of the theorems, which is what was the most important thing. So anyway, that gives you a little bit of background as to what's going on. I was shocked to find it out that way, because I didn't think that was correct. I didn't think that would possibly be going on in the scientific community, but it was. And when I gave a talk one time before the American Physical Society at the Washington, D.C. meeting of the American Physical Society, I pointed out that the theory of relativity we knew was false, both special and general. It just has to do with what you get when you solve all the empirical equations of electrodynamics simultaneously, which is what Isaac Newton said to do. And but they didn't do that because they didn't know how to do it, because they were differential equations and non-differential equations, and they just didn't know how to make them work. And so and over time, some of those empirical equations were improved. And my book which I showed you here, as the proof for the universal force law being electromagnetic. So, and I'm producing new theories of the atom, the nucleus, elementary particles, molecules, just a lot of things that we missed, and because we avoided looking at the proper things, we took the role of logic out of science so that we don't have to be self-consistent with the other things that have been observed in our science. So that's kind of where I'm coming from. And so I haven't finished writing my books on the theory. I'm doing a book on the elementary particles. I've published some stuff on the theory of the atom already. I've done theory of molecules, and just all these theories that we are teaching in our universities are false, and we won't even let you know how to use logic to show that they're false.
Yeah, looks like Harvey's got a question.
Okay.
Two things. How do we get beyond relativityism? I would say that, like, there's experiments like Super Ko Commande and stuff like that, where they measure high energy particles coming in. They're like 1 kilometer under the rock of a mountain and stuff, but they can actually see these light cones. And I think what we need to do is start actually doing real calculations using Newton mathematics plus the center of the light as it, plus as the particle's moving, you have to include the velocity of the particle added to the speed of light, as these chain reactions are happening. If we can just show calculations that consistently say a certain source in space is really providing energy that is moving at 70 times the speed. Different objects that, using the equipment that exists without going through relativity, because in relativity, what I see people doing is, if something can move faster, can move further than their lifetime over a certain distance, they say its clock slows down. So they fudge everything, and they're really messing everything up. What's really happening, which goes back to the microwave background radiation. I think in the very beginning, or the cosmological event, it wasn't at a quantum dot, it was all over space. And what we're really seeing when we observe particles, the particles that we observe are the energy density capacity that space has. And there's energy flowing in and out, and the net difference is what we see. It's the difference. And so I asked a professor when I was in undergraduate school at Texas Tech, I said, there's this experiment where laser light can come in, right? And then you split the beam and you get this parallel path like this. Yeah. So that it goes over here, it comes out. If the net effect is a cancellation of fields, so you have E cross B, the net effect is 0 over here. They said, well, because of quantum mechanics, nothing goes out in that direction. And I said, no, you're wrong. I said, the energy's here and the energy's here, and it's going here, and it's canceling is over here, that's exiting. And really what I think is, it's the electromagnetic fields can never truly cancel. So I'm thinking this is in your book. So what I think is electromagnetic gravity is nothing but either cross-polarized. They have to be in two pairs. The reason why, I've got proof of that too. Birkeland currents by Dr. Donald Scott are plasma currents that we see and measure in the universe, like down spiral arms of galaxies, or between stars, or whatever, or between galaxies. They have a 1 over the square root of x in the Bessel functions that feed the currents, and it's a pair of magnetic fields that are orthogonal. So you'll have like in a transmission, this will be quick. Bear with me another 2 more minutes, maybe. These fields are orthogonal. They're rotating the center of the Birkeland current, which has plasmas that are ionized gases at the energy in this way and that way, with a net magnetic field in the center that's in a certain direction. It's called field align because it's electric fields, but that's 1 over x squared. So if you had a pair of Birkeland currents feeding in and out in both directions, there would be 2 pairs, which would be 1 over r squared. That would be the field strength as you get further away. And so I think the original microwave background radiation is basically the afterglow of energy conversion into matter that stored it. So therefore, G is nothing but like the sum of 4 electric fields that are canceling. And you get the 1 over r squared, and you get the weak field because it's canceling electromagnetic fields that don't totally cancel. And so neutrons, and then I'm done, is nothing but the hydrogen atom that had so much energy compression in the very cosmological beginning event that the electron was trapped at the surface of the proton, and its velocity probably would prove the micro background radiation. In other words, it's hyperlight. The electron is exceeding the speed of light, the surface of the proton. So therefore, it's unstable because if it's free of these other protons and electrons that were made with it, that are in pairs, there is no such thing as antimatter, and I'm done. In other words, the antimatter itself is a mathematical construct. What we see are real particles made in quadrupairs. In other words, you had hydrogen atoms made and like 4 of them made at the same time. One turned into the neutron because the pressure was so great. And so you had the net result was the creation of water molecules, which are all over space. And now we're back to the creation story, and no one's going to buy it. That's it. That's how simple it is.
Well,
So I want your book. I want your book to see what it says.
you can buy it on, let's see,
Amazon,
pardon?
Amazon.com.
Yeah, but it was originally done,
Was it done on Lululemon?
no, it was the big publisher at the time.
Oh,
Um,
But thank you very much, Bill, for letting me.
yeah,
And I do, when I'm hearing you, I see the 1 over r squared brought up, which is really 4 times 1 over x to the square root of x.
uh-huh.
I see Bessel functions coming in. It's the Bessel function itself that feeds the Donald Scott. I can send everybody a link to the paper here in a minute when I quit waving my hands. What it is you've got like in a machine, you'll have the stator, then you'll have the rotor, and then you'll have the current that's going like this. So you'll have the on-axis field and the off-axis field. It's called the D and Q axis. And that's exactly how Bessel functions work. You have the peak here, and then you have the 0 here. It's the 0 field and then the 1 field on the Bessel function. Well, that's actually 90 degrees. So it's a combined field that's rotating into the center. And it's a 1 over r squared, x squared, r squared combined field. And so anyway, it's the afterglow or the cosmic microwave radiation where you had energy coming in this way in all directions, where the fields maximized, particles popped in, they stored the electric and magnetic energy. So therefore stars are actually polarized. They're different potentials throughout the whole universe. The galaxies, it's called the galactic, the supergalactic web or cosmic web concept. So anyway, that's E. It was energy converted, and we're seeing the stored. So I want to see what this cosmic microwave background in your theory looks like. I want to see, because I think it's just the energy that's still being reflected. And I wrote a small 3-page paper that shows empty space free of anything. Epsilon and mu naught they don't exist. Before matter, there was nothing but space and time. Then there was energy, light, we call it light. That energy created the matter, popped out of it. And so therefore, where was I going with that? The velocity of that energy was near infinite. 1 over the square root of 0 times 0 is even more infinite. So, because to have a magnetic field from a moving charge, the charge has to exist. If the charge doesn't exist, there is no source. If there is no source, the magnetic field in free space can exist, but it has to be from energy, where the energy vector, the electric and I think the magnetic field is nothing but an off axis of the electric field. That's what I think it is. I'm working on that in my mind right now.
Well,
sorry.
thank you for your comments. And we have made a lot of progress. We have a new theory of the atom that is different from the current theory, and we're able to predict the islands of nuclear stability that cannot be predicted with the current politically correct theory of the atom and the nucleus. And
What properties are you talking about?
The islands of stability.
yeah, the ones if you look at what we see when we run experiments with accelerators and everything, we can make heavier and heavier nuclei and atoms, but some of them are semi-stable that we make, and they're not predicted at all by the current theories, but the theories of the atom that I've published, it is able to predict those. And there are thousands of these islands of nuclear stability that can be predicted, but you're never told about them when you take a course in nuclear physics. And so, you know, I've put them in a PowerPoint, or no, not a PowerPoint, but
Video?
no, it's a calculation tool that goes with science. Anyway, I've listed all of the observed nuclear isotopes and also elementary particles, and we predict many that the current theories do not predict. And I mean, there's like thousands of them, and so you put it in one table, it's hard to see it all. You can put a graph of it, but you just it's hard. But anyway, we're able to do that, and so the scientific community is not willing to accept these newer theories involving a universal force, and that I think is difficult to overcome. And so if people like Elon Musk can deliver to these 1,252 companies that paid $1 billion each to be in the working together, and permission to use it and sell it, things will be, I think, much better, because once a lot of money is being made, people will want what that is. For instance, I would love to have one of their cars that would last a lifetime, and I don't have to buy anymore. I don't have to buy any fuel or anything like that. But I haven't gotten one. One of my children had a Tesla Extravaganza, which was a pretty elaborate one. It's the only one, the first car I know that you can take your cell phone and tell the car where to go. And it'll go on the road. It'll follow all the street lights, the speed limits, and everything like that. And it would go from from the Pacific to the Atlantic Ocean, you know, all the way across the country. It's just amazing. But you have to recharge it, and so you have to let it get recharged at certain charge centers.
How long does it take to recharge it?
About 10 minutes.
Oh,
And then it'll go 500 miles or more. And so anyway.
So Bill, getting back to your book here. So, I
Yeah.
have your book here, but I still have the question, your title is, the universal force. But I'm still a bit confused as to whether you're saying that there is a force that's, I don't know, not electrical, magnetic, because the mainstream recognizes, 4 forces. But when I look at your book, I don't see any claim as there being a separate universal force. I just see a lot of math and Maxwell's equations and such. So what would you say? What's the relationship of, say, the title of your book, The Universal Force, to, say, the 4 recognized forces?
But Bill, isn't your universal force electromagnetism?
Yes.
Okay.
But is that there's 2 forces there? There's electricity and then there's magnetism. Can we derive it down to like one of those, or is it?
Well, if you look at the work of Poincare, where he's showing in meta theory how to prove different things, he shows that in order to have a force, you have to have something that is continuous in the universe, and you can't have action at a distance.
All right.
And so there's a lot of things that you need to look at, and Poincare showed from meta theory, I think he did more than 10 theorems that apply to most of physics, and as long as he was living, he really controlled the stage in Europe. But he died around 1910, somewhere around in there. But he disproved, for instance, one of his theorems disproves Einstein's general and special theory of relativity. But the effects and the equations that you see, you can't have more than one fundamental theory that has a 1/r² dependence.
Yeah, so the only one that I know about is the electric field. So
Yeah.
Bill, I just want to ask you the straight question. Is the fundamental universal force, as stated in your book, the electric Coulomb force?
It's but Coulomb is he has a different version.
1/r², because you said
Yeah.
the only one thing can be
Right.
1/r².
Right.
The only law that I know about for force is the electrostatic 1/r². So
Yeah.
is the universal force that force, the force that comes out of charges?
Well, you see, the continuity in the universe is charges are just like bumps on the universal field, and where the field is in a state where it pauses for a while. I mean, you have an elementary particle, or you have an atom, or whatever, and so this people in Spain were also followed to what Poincare did, and they showed how you could explain the structure of the elementary particles at that time, and that sort of thing, and atoms. And in the current theories of the atoms we have particles orbiting around a nucleus.
Yeah, that's crazy.
Yeah, and there are a number of logical inconsistencies with that, and but if you have it as an electromagnetic structure where the field is there and you don't have particles moving.
Well, I guess I'm getting to, what do you mean by electromagnetic? Because I suppose that electromagnetic is recognized as one of the forces. Although I would argue that magnetism is a composite force. That magnetism is a different force than the electric force, but that you can say build the magnetic force out of the electric force. Thus, which is why I'm asking you, is the universal force just the electric force? Which is kind of like my spiel.
Well, it has to explain gravity. It has to explain the electric field of things and magnetic field things.
Yeah, it has to explain gravity, I think. Yeah.
Strong interaction it has to explain. And
strong interaction doesn't exist. A weak interaction doesn't exist either. So that explains those two.
Well, if you go to college today, they'll tell you they exist. So
oh no, the strong force is the ridiculous force that holds protons together, which, if you think about it, at the distances considered, would repel each other with like the energy of atomic bombs. But it's never actually been measured, right? So it's like, Bill, you don't have any actual experiments which say that we've measured this ridiculous force, which is super strong at close distances, but nothing at greater than atomic radius distance, right? This is a completely ridiculous force.
Well, the Spanish government has supported people that do that. And one of them spent a year over here in the Spanish embassy in Washington, D.C., and I got a chance to talk to him and see all he had to say. I have. But
I'm still trying to get to the question is the electric force the universal force?
Yes. And right. It's not just electric, it's electromagnetic, gravitational, all of that in one.
Well, it's all caused by one thing, right? And no, I'm just asking you, is that one thing the electric force? So does the electric force create gravity? Electric force create magnetism? Electric force, well, I wouldn't say it causes the strong force because, like I said, I don't think that exists. But do you think your universal force causes the strong force? And how do you explain that?
Well, I've been able to. I've published a theory of
yeah, we have to go to the next meeting.
And a theory of the nucleus, and able to explain much more data than the current theories that are being taught. And so you see, God left his fingerprint on everything that he created. And when I was in high school taking biology, I did a science fair project in biology, and I was helping my father build a house, and we had a forest on the land, 2 acres of land that we were building the house on, and we had to cut the trees down and everything. And I noticed in cutting the trees down that the leaves on the tree had a certain symmetry in the structure of the veins. And then there was a certain symmetry in where the leaves were on each branch of the tree. And so, by the time the King James Version of the Bible was translated, we didn't know what a fingerprint was. So it turns out that in the early 1900s, Great Britain was ruling over India. And they had a problem, and that is when they were paying people that were working for them, they were dark colored, they all looked alike. They couldn't distinguish them very well. And so some people were coming up and getting paid who didn't do any work. And they needed a way to fix that. And what they did, they came up with the idea of doing a fingerprint, and they discovered that the fingerprints were unique. And so they used that to make sure they paid the right, the right people. But after a while, the FBI in America and the equivalent organization in Great Britain started using it on people, because then they could identify who broke in, who did something or killed someone or whatever by the fingerprints on the guns or the doors or whatever. And so after we learned that, then this statement in the Bible became more interesting. And Moses showed that God's fingerprint was on the tabernacle, and also later on Solomon's temple. And according to what the Greeks had to say about what Moses was saying along the trading route, the type of symmetry in the fingerprints that were representing God were chiral symmetry. Chiral symmetry involves symmetry based on the numbers 1, 3, 5, 7, 11, 13, 17, 19, etc. And so what I found when I was looking at these leaves from trees is I found those symmetries on most of the trees, but some of the trees didn't have it. It was different. The tree had been altered, and it originally had that symmetry. And so I did a science fair project, as I think it was in 9th grade, and showed the what the symmetry was. And not only is that pattern in leaves based on that, but it's also in molecules, and many of the plants that were used for medicine in the past, like in the when the children of Israel were in Egypt as slaves, they also provided the medicine for the people of Egypt, and they were able to cure every known disease. And on the side of the pyramids, they showed the apparatus and the techniques that they were using. And they also used eels, electric eels, to do electrical therapies. And so this leaf pattern that is in the branches, it turns out when I was doing a theory of molecules, the molecules have the same types of symmetry, and the molecules of the what they got out of various leaves that they used for making medicine, they had that. But when we started using pharmaceuticals and that sort of thing, we wanted to patent the medicines that we made. So we made them artificially. And when they were made that way, they didn't have chiral symmetry. And the ones that don't have chiral symmetry, they do some things that are helpful, but they're dangerous, and they have some disastrous consequences that they sometimes find. So the fingerprint was no longer as effective in the medicines that we made by the pharmaceutical industry. And for that reason, we have not been able to make medicines that could cure every known disease like we had in the past. And so, but when we look at molecules, we see symmetries. We see chiral symmetries if they're natural, and if they're like a tree where you did an implant in the tree, and now you're looking at the leaves and the fruit on the implant as it grows, you find that it's different, particularly if the implant was a different fruit tree or something like that. So anyway, the passage in the Bible seems to indicate that the things that God made had this particular symmetry based on numbers 1, 3, 5, 7, 11, 13, 17, 19, and higher. But they're numbers that cannot be divided by 2 or 3 or 4 or 5 or 6.
I know.
They're unique, and so that I found that very interesting, not knowing very much about it when I was in 9th grade, but just, because I was cutting trees down and getting the leaves off and all that kind of stuff, I collected them and made a collection of it. So but when it comes to the theory of the atom, your theory is not going to work if you cannot explain the chiral symmetry that we see naturally. And so that's why you need a new theory of the atom and a new theory of molecules. And so I just wanted to point that out because we don't know about that when we go to school. And it's something that's not explained, but people like me have done science fair projects on it and stuff like that. And it's not unknown, but it is unknown why we have this kind of symmetry, and does it come from the universal force? And since the Bible talks about it, it's very likely it does come from the universal force. And so we need to do a theory of molecules that enables us to see that. And so anyway, that was one thing I wanted to talk about. And we have been mentioning the problem when you have a new theory and it explains the previous data that theories explain, but it explains more. And then there's overlap with multiple theories. Like in the case of the universal force, you've got the force of gravity, force of inertia, electromagnetic force, you've got strong interaction force, weak interaction force, all these forces, and that you can sort of explain a lot of the data by having them as separate theories and not overlapping. But from what Poincare was able to show, there's really one universal theory that's going to explain it all, but you have to perform more experiments and find out what it is that you're missing in your theory, so your universal candidate will be more accurate. For instance, when I was doing electrodynamics as a universal force, some of the force laws in electrodynamics, the empirical laws, were updated. And I found it was necessary to take into account the updated version because it wasn't, our universal version was incomplete. And so we have to do that. And we don't know if we've found everything out about the electromagnetic force, but so far we've been able to explain almost everything that we should explain with that type of theory. So now the question is, how do we make progress if we even publish the theory and get it properly acknowledged by the scientific community? And that is, even though those who understand the theory realize that it's very logical and it seems to be complete in that regard, the community wants to have 5 theories, not 1, or 10 theories instead of 1. They want them to be separate because then they can make different views. They don't have to recognize the role of God doing anything. And that's one of the things they don't want to recognize. And so I just mentioned that to you. I don't know what kind of religious background you have, but it just shows how there are certain problems and there's certain people on both sides of the problem, and they're not always in agreement on what they want science to do. And when we went to the existential scientific method, we wanted to promote the God is dead movement. So the same people that got us to do the existential scientific method also were the founders of the God is dead movement. And so you see politics there. And today we have a lot of politics in science. And you can't get a grant if you want to do work that the granting government agency doesn't want to see done. They want to keep their theories that they've already approved. And,
Yeah, I'm all in favor of God, Bill, but I'm not exactly sure that chirality really points that out. I mean, I suppose my attitude is that, yeah, God is in charge of the world, but he did so by setting up a physical system that can kind of run on its own. So, God can sit by and watch TV while the world goes on its own. It's like he can put, like James suggests that, the universe is like a computer, whatever. And, perhaps God would serve as the ultimate programmer to that system. Although I think it's interesting to see whether, could try to prove the existence of God by certain things that you observe. But I'm just not quite sure that chirality, which is just basically based on, left and right hand, these two cannot be the same, is what chirality is about. And things like molecules, that might just arise just because, I don't know, geometry. That's the lowest energy way of doing things, perhaps, or something like that. But that's kind of my thought.
Well, the reason why I'm interested in it is I'm trying to promote these theories, but I can't go to a university anymore in America. They will lose funding if they let me come and speak there. And every person I work with to publish papers with, they lose their job if they have.
You don't have to worry about that. No one cares about my theories, and my job doesn't depend on it. So,
right, yeah. Well, I had to do something else. So my income came from computers. I was the inventor of the super micro computer, which for over 50 years has been the world's fastest computer and most capable. I can replace entire computer centers.
Yeah, so you should be richer than Elon Musk. What happened?
Well, do you know what happened when I replaced 500 computer centers in NOAA? The head of NOAA called me into the office and said, "Don't you know the government's not about saving money? We give money out under the table to all kinds of people." And he said, "If you don't leave, you're fired."
Yeah, you did your job too well. Well,
And,
now we're all walking around with exactly that same computer in our pockets now. So it eventually came true.
Well, no, my computer, which came out in the late 1960s, it had 65 80-bit processors. This is a solid state. I had to do everything. I had to make the motherboard. I took the solid state memory and I wrote 52 algorithms to compress memory so that I could get a 41 compression rate. In other words, if I had a 1 terabyte memory chip or whatever, I could make it 41 terabytes. And I could get to do a lot of the work of the operating system in the CPU. And so I was able to get a computer to run 1,000,000 times faster than the other computers using the same chips if they existed.
Although, Bill, I was really kind of interested as far as computing goes. What is your reaction to perhaps my suggestion that that God is just the ultimate programmer? So he doesn't have to keep his fingers on the knobs. So,
well, I found it's very hard to make a computer work to do all these things. I got my computer that I replaced the computer center with ran 48 simultaneous operating systems and handled up to 5,000 users simultaneously on each of the 48 operating systems, all in one computer. And the problem that NOAA was having was they had to support all the satellites in space. They had to keep track of where they were. The problem they were having with their computers was round-off error, and they would lose track of where their satellite was, and it would just fall to the earth. And but I was able to handle that, and also I was able to handle all the data that they get down from each of these, and then distribute it to whatever organization was supposed to have access, whether it's the military or the weather service or whatever. And so that was quite interesting. And there was a time when a big computer conference was held in Washington, D.C., or at the was it NIST? One of the government agencies that handles a lot of computers. And I would be an invited speaker, and the other leaders of the different companies like IBM or Microsoft or whatever, they would speak. More people were interested in what I was saying than all of them put together. I would have thousands of people in my auditorium, and they would have hundreds in the same size auditorium. And they couldn't. The people wanted to see something that would really do something.
Bill, I got a couple of general questions.
Okay.
About the construct of energy. Do you see that as a fundamental construct that exists in physical reality, or is that a man-made construct? You're talking about universal force. Does the universal force, is that driven by energy?
Well, the universal force, it appears that the field, like the people have interpreted the electromagnetic field as the spirit of God, and this field has what do you call them? Various structures that are produced, and those structures form what we call an elementary particle, and then of course we got an atom and the nucleus and all that from that. And so all phenomena are, and this is continuous. So the electromagnetic field that we experience at the Earth is coming from all over the universe.
Mm-hmm.
It's all one huge batch of electromagnetic fields from one source. And so that's what we are seeing experimentally. And so, for instance, the idea of the Big Bang and stuff like that has to be electromagnetic, and but we don't always look at it that way. And so there's just a lot of things. I can't claim that I've worked on everything that you could do, but I've worked on quite a few, and they seem to, the electromagnetic explanation seems to work. And particularly when I was speaking in Canary Islands in Spain, I met people that were showing how all of this caused the various structures that we see. And the structures are, at one level is elementary particles, and another level it's what when we use the theory of elementary particles, we use I can't think of the name of it. It's a smaller entity, but anyway, we have theories of the nucleus and elementary particles where we have these other particles that they're made from, and we keep going down smaller and smaller and making more particles. But it appears that this structure can be different sizes, but there's only certain types of structures that can exist in this universal field.
Right, but when you have those structures, say, moving or changing, uh, are they changing by energy be acting on them?
Well, if God is the source, then
Mhm.
God can change things through this electromagnetic field, and like for instance, we talk about elementary particles being made of quarks
Right.
and smaller things, and then if you get to too much detail, you need something smaller than a quark, and but with the field, we are able to explain everything for which we invented quarks, and the theory of quantum mechanics is merely a part of the electromagnetic field and standing waves and various structures like that occur in the field. And so I'm hoping, I have 5 books I want to publish, and I'm hoping that there's one on the universal force, one on theory of elementary particles, one on theory of the nucleus, one on theory of the atoms, and one on medicine.
It's sort of ironic that Russia, which has virtually no freedom of speech, has freedom of speech in the science area. Maybe the politicians don't think that, a new physics theorem will upset things, at least not since Lysenkoism was disproved. But doesn't that give Russia and maybe even China an advantage over the U.S.? Because in the U.S., politics and political correctness has taken over the science academia.
Yeah. Well, that's true, and that seems to be their interest when they hold these meetings. They'll bring people in from many countries who are doing current edge of scientific work, and they try to learn as much as they can from them, and if they make further progress, they get invited back again. And so that's what I see they're doing. But other countries, there's politics involved in this, and they don't let the politics affect the sciences in Russia. They want new technologies that can do things that they want to do. Maybe it's making weapons, maybe it's getting
exactly. So that represents a real risk to having censorship of science in the U.S.
Right, that's right. Yeah. But we have that all the time, it seems like. And in the area of medicine, we have that problem. And so if you have certain diseases, you go somewhere else. We've had presidents go to Europe because they would cure the disease, but you couldn't get any doctor to do that for you in the United States. They would lose their license to practice medicine. And so they say it's all about the money. The Food and Drug Administration is trying to keep their industry alive.
But that's not going to help them if Russia comes up with a super weapon that we can't defend against. Then
that's right.
All the money goes down, all the dollars go down the drain.
And politically, right now, we are very low on our weapons. Russia has more than we do.
Oh, yeah.
And Russia doesn't have a very strong economy. But they were able to give priority to making these weapons. And so we could end up not doing very well with a war with Russia, because if they can blow up all of our major cities like they're doing in Ukraine, it'd be kind of sad.
Russia has more than half of all the nuclear weapons in the world.
Yeah. They're getting older though, so maybe they won't use them. Well, that's about all I wanted to say was I saw there's been an influence of the Bible, particularly after it got translated to the local language of people, and we have made some progress in science with that using that information and that point of view. And also the work of Poincare, Henri Poincare, with his meta theory, that seems to be an area that has been just overlooked in current days. And I think his theorems in meta theory would help us see which of our work in science is out of date and not true. And so I think we have in science a number of theories that are false, but they're approximately right in some way. You know what I mean? You can use them and make progress in industry and stuff like that. So I appreciate all of you coming and attending the meeting today.
Thank you, Bill.
Okay, well, thank you for the opportunity to speak and to share. And I always enjoy doing that to a certain amount. And I learn things from people. You know, you have to be humble and honest. And some people will point out things that you didn't get quite right or something like that, you know, and you need to take that into account. And over the years, I've had people, even like Dennis Allen, point out things that I had done that were poor, and I've corrected it. And so I appreciate the interaction with other people who are trying to do similar types of things, because then we can make progress by helping one another.